Today we will discuss about covariance and expectation, which is lecture 2 of third module. We already discussed what is joint distribution and how to represent a discrete and continuous distributions, and what is marginal distribution, which is distribution of one variable taken out from joint distribution, and what is independent of random variable, independence of random variable. Okay. Today we will discuss expectation and covariance. We already know that what is expectation of one variable. Expectation of one variable defined like this: expectation of x equal to integral over x into f of x dx. That is, the function here should be multiplied with probability density and should be integrated over the range. Here x square is the function, so x square into f of x, the probability density, and multiply integral over x. That's all. The very similar equation or same equation will work for both x and y, means two variable functions also. So let x and y be two-dimensional random variables. Then g of xy and g of xy is a real valued continuous function. Then if f of xy is discrete, then expectation of g of xy equal to sigma over I, sigma over j, g of xi yi into p of x equal to xi, y equal to yi. That is, the function should be multiplied with corresponding probabilities and sum. Okay. In case of continuous random variables, expectation of g of xy equal to integral over x, integral over y, and the very same formula applies. That is, function should be multiplied with the corresponding probability density. So the properties of expectation. First property is expectation is linear function. So expectation of a constant into first function plus a constant into second function is, constant can be taken outside and you can split it by plus. So alpha, expectation of alpha g1 of xy plus beta into g2 of xy equal to alpha into expectation of g of xy plus beta into expectation of g2 of xy. If x and y are independent, then expectation of xy equal to expectation of x into expectation of y. It's easy to prove that when we are taking definition of expectation of xy. Expectation of xy equal to double integral xy into f of xy. So here, when x and y are independent, the f of xy can be divided into f1 of x into f2 of y. So expectation of xy can be divided into a function of, that means a integral of x contain x into f of x, and in another integral of y, that is integral y into f of y, and that both integrals equal to expectation of x and expectation of y respectively. When comes to variance of xy, take these equations. I know you are not familiar with what is covariance of xy, which will be discussed in this lecture itself. So variance of x plus y equal to variance of x plus variance of y plus 2 into covariance of xy. Variance of ax equal to a square into variance of x. Okay. You can, when the constant is taken outside, it should be squared. If x and y are independent, then variance of ax plus or minus by equal to a square into variance of x plus b square into variance of y, which is applied only to independent. You should remember that this equation is only applicable to independent variable. This is because of this covariance of xy becomes 0 in case of independent variables. So, and this equation of the expectation and equation of variance have some difference. When the constant is taken outside in expectation, you can take constant as it is. In case of variance, it should be squared. When the constant is taken outside, it should be squared. And second thing is that plus or minus. You can, even if this is minus, this becomes plus. Basically, this minus is absorbed in b, and when it's squared, it will go out. So let's go to a simple example. So discrete case example, let x and y are random variable with the probability mass function which is given in this table. We need to find expectation of x square y. Expectation of x square y equal to summation over y I summation over j xi square yi square yi, here x square y, that's why xi square into ya, and corresponding probability we need to summation. We will do it in this way. First we need to take this element, so xi equal to x1, that is x1 y1, x1 y1, that is 0 square x square into y, 0 square into 0, that is 0 square into 0 into this 1 by 2 corresponding probability, and taking second element, this one, so this is the x value, so x square y, so 0 square into 1, 0 square into 1 into corresponding probability. And the third case, which is third element, is this one, so here x is 1 and y equal to 0, so 1 square into 0, 1 square into 0, this one into 1 by 8, that probability. In third case, last one, fourth element, x is 1, that is 1, this one, x square y means x equal to 1, y equal to 1, x equal to 1, this one, y equal to 1, that's 1 square into 1, and corresponding probability 1 by 8. When we calculate that thing, this all will go because it contains 0, and you will get this one, 1 by 8. So expectation of x square y should be like that. From here and here, you should take the function and corresponding probability. This should not be altered. You should not square this one. Please remember that this should not be squared or any change in this one. Only we need to take the function from these two variables. If x square y, then x square into y. If x cube y square, then this should be squared and this should be cubed. Like that. Then should be multiplied with this and sum. So it's very easy to calculate in discrete case. Let's go to a continuous example. If two random variables x and y have joint density function f of xy equal to xy by 98, 96, 0 less than x less than 4, 1 less than or equal to 1, 5, 0 otherwise. Find expectation of xy. So expectation of xy equal to integral over x, integral over y, function, that function xy, into corresponding probability. That's all. So we'll substitute all that thing, xy here, this xy here, and f of xy equal to xy by 96, that is here, and it's multiplied x square y square by 96. When we multiply by, you already know that what is double integral. You need to take y constant while integrating over x, and you need to take x constant while integrating over y. Likewise, you need to do that. First you need to integrate. This can be integrated both on single threads, as these limits are constant and this function is separable, so it can be integrated in straight way, or the other way also possible. First you integrate x square and y square and apply limit, and then integrate over x square. That is also possible. Finally the value will be 9.1852. And covariance, what is we seen in equation of what? Equation of variance. What is covariance is? So covariance of xy equal to expectation of xy minus expectation of x into expectation of y. And if x and y are independent, then covariance of xy equal to 0, which is also called uncorrelated. Covariance is, converse is not true. That is, even if covariance of xy equal to 0, you cannot say x and y are independent. That is, there is a small gap in that equation. That is, even if expectation of xy and expectation of x and expectation of y become 0, this covariance of xy equal to 0, and you may get covariance equal to 0, but x may not be independent of y. One example, you may try out an example like that. When first variable is x and second variable is x square, take y equal to x square, then covariance of x square you need to calculate, then you will get it's 0. But we all know that x is not independent to x square. So if you need to you need a converse, then take x as a uniform random variable in -1, 1, and take y equal to x square and work out the remaining. You need to take x as a uniform random variable in the range -1 1 and take the y equal to x square and check with what is covariance of xy. You will get 0, and but we all know that x and x square is not independent. Any change in x square will be reflected in x also. Here what is covariance? The covariance is xy is a measure of how far x is dependent on y. The change in x will be dependent on y. When x and y do not have x don't have any influence on y, then the covariance is very less. When x equal to x square, there will be very high covariance. There should be very high covariance in general case. In general, there are exceptions. When x is very much dependent on y, the covariance will be high. Okay, considered as high. So when covariance is 0, then there is a concept of negative covariance. That can be negative also, I think, because expectation of xy is it should be actually this what correlation is a very interesting topic when you come to some fields. If one variable is affected by other variables, so when we discuss, we may need to calculate or observe a phenomenon, and we need to check whether the variables or parameters of the nature where the phenomenon occurs is related to that. So the covariance will be useful in describing this in several situations. And okay, and as an example, join probability density function of a random variable x and y is given by this function. Okay, so there is a typing error. This should not be there. Okay, f of x y equal to 3 into x plus y, 0 less than x less than 1, 0 less than y less than 1, and x plus y less than 1, 0 otherwise. Find the margin distribution of x and covariance of xy. This statement is typing error. Okay, so first we need to sketch the area where the probability lies. So which is given by 0 less than x less than 1, 0 less than y less than 1, and x plus y less than or equal to 1. So 0 less than x less than 1 and 0 less than y less than 1, and this is x plus y equal to 1. This will be from 1 0 to 0 1, a straight line from 1 0 to 0 1. X plus y less than or equal to 1 means the area lies below the straight line, and it will be marked as R. Oh, so we need to integrate in this area. That's all. You know what will be the integral in this area? If we check double integral limits, so if we check dy first, then this will be, that is type 1 region, then y should be considered first from 0 to this straight line. This straight line is x plus y equal to 1. So when we take integrate y first, then y equal to 0 to x plus y equal to 1 should be converted to y equal to 1 minus x. So 0 to 1 minus x. So that's marginal distribution. First we need to calculate margin distribution. Margin distribution fx of x. Sometime I use f1 of x also. That's just a notation. That's all. Okay. That is 0 to 1 minus x. That is limit of y. Limit of y is, from this straight line 0 to 1 minus this straight line. So into the function, this probability density function. So we need to we are calculating marginal f of xy over integrated over y. Then the integration is taken out 3 into xy, 3xy plus y square by 2. You get y square by 2 and 0 to 1. 3 by 2 into 1 minus x square. Okay. Now expectation of x. Expectation of x can be calculated from the marginal distribution of x. Okay. So margin distribution of x is given by this one. So you can calculate one variable example. One variable expectation of x equal to integral 0 1 x into fx of x dx. That is equal to integral 0 1 3 by 2 into 1 minus x square. Integration, if you perform integration, you will get 3 by 8. Similarly, This function is symmetric. This 3x plus y is symmetric. So whatever calculation we do, similar calculation can be done by to y also. We need not calculate again. Similarly, expectation of y equal to, here the integration should be over x, then the limit should be 0 to 1 minus y, and this you need to integrate over x, like that. If you change the result, you will get expectation of y equal to 3 by 8. Now expectation of xy equal to double integral over r xy into f of xy dy dx. That is, we need to calculate this the expectation of this function xy, and this is the probability density of that. So in r, the limits are 0 to 1 and 0 to 1 minus x, xy into 3 into xy, x plus y, dy dx, that is equal to 3 into 0 to 1. When we integrate xy into 3 x plus y, that will be x square y square, 3 can be taken outside, x square y square by 2 plus this will be xy square, xy cube by 3, and y equal to 0 to 1 minus x. If you apply limit, you will get 1 by 10. And the covariance is expectation of xy minus expectation of x into expectation of y. So here we get expectation of xy, and expectation of x you get from here, and expectation of y, which is very similar, 1 by 10 minus 3 by 8 into 3 by 8, that's equal to minus 13 by 320. I already told that covariance can be negative. That is a negative correlation. If one variable increase, the other variable may decrease. In that similar case, the covariance will be negative, and it will be have a negative correlation. Another example, a factory has 2 outlets to sell its products. The daily sales from the first outlet is uniformly distributed between 50,000 and 60,000, and from the second outlet it is uniformly distributed between 40,000 and 60,000. The sales of the outlets are independent. What is the probability that sales from both the outlets combined is more than 1 lakh? B part is, if 20% of amount from sale is profit, find the expected daily profit from both the outlets combined and the variance of the profit. Please read this question and take a moment to think about that. Okay, now first we need to define random variables in such questions. Let x be a random variable, denote sales from first outlet, and y be a random variable, denote sales from second outlet. So what we need to calculate that x plus y should, in a part, x plus y is greater than 1 lakh, and second part is 20% of x plus y, whatever it is, x plus y into 20 means 20% x plus y, expectation of that is what expectation, and I think variance also we need to calculate. Expectation and variance both we need to calculate. So let x be a random variable of x, we defined already random variable, and given that x and y are uniformly distributed, that's a crucial information, then only we can calculate joint distribution. Otherwise, if x and y are dependent variables, and if we don't know their distribution, calculate. what is joint distribution. Here x and y are uniformly distributed, so we can calculate the distribution of x from the range. Uniform distribution means we need only a and b, then 1 by b minus a will give the probability density. So in first, f1 of x is 1 by b minus a equal to 1 by 10,000, a less than x less than b. This is the probability density function of uniform distribution, and 0 otherwise. Similarly, f2 is in the interval 40,000 to 60,000. So the probability density is 1 by b minus this b minus a, 1 by b minus a, like that. And the joint distribution of x, y, since we are given that x and y are independent, therefore the joint distribution can be calculated by f of x y equal to f1 of x into f2 of y. So we need to multiply this both two in order to get the joint distribution. That is f of x y equal to, we need to multiply 1 by 20,000 and 1 by 10,000. That is equal to 1 by 20,000 10,000. That is 5 into 10 raised to minus 9. If x range and y range should be given separately. This is y, sorry, it's a typo error. 50,000 less than x less than 60,000 and 40,000 less than y less than 60,000. And in order to calculate probability of x plus y greater than 1 lakh, we need to sketch the graph of that one. Okay, first we are sketching the graph of this range 50,000 to 60,000. X is varying in 50,000 to 60,000 and y is varying in 40,000 to 60,000. For simplicity, I am taking it as 5 to 6 and 4 to 6. So it will be like this. This the area 5 to 6 and this the area 4 to 6, and the distribution is uniform. So probability of x plus y greater than 1 lakh. This is x plus y equal to 10. We need to calculate x plus y greater than 1 lakh. Similar when we convert to here, x plus y, we need to calculate greater than 10. This area, we need to calculate this area. Okay. So probability of x greater than or equal to y equal to 10,000. In order to it's better, easy to integrate here than here. Okay, because this area is tetrahedron. This triangle will be simple and straightforward. So x plus y greater than 1 lakh equal to 1 minus probability of x plus y less than 1 lakh, and that is given r is this area. So 1 minus that, we need to integrate f of xy in that area. That is equal to 1 minus double integral over r. This is the probability density function, and you need to integrate it out, and you will get 1 minus 5 into, this is a constant, you can take it outside, and double integral dy dx is area of this triangle. So 1 minus, this is that constant taken outside, and the area of triangle r. Area of triangle can be calculated by half bh, and that will be 1 minus 5 into 10 into 1 by 2 into 10,000 into 10,000. 10,000 and 10,000 into 10 raised to minus 9 will be cancelled out, and it will be 5 into 10 divided by 2. That is equal to 5 by 20. That is equal to 1 by 4. That is equal to 1 minus 1 by 4. That is 3 by 4. So the probability 3 by 4. Since it is uniform, it will be proportional to this area. You can calculate this area and this area, and the ratio of this area will be what we want. So this area is 3 by 4 of this square. That's all. So only because of this f of x y is constant, we can take it outside the integral. Double integral of r will be the area of equation, and we will go to the profit. Okay, so it's given that 20% of sum of sales is profit. So we know the sum of sides is x plus y. To get 20%, 0.2, we need to multiply 20 by 100. That is u equal to 20 by 100 into x plus y, that is equal to 0.2 into x plus 0.2 into y. Okay. So expectation of u, we need to calculate expected profit, that is 0.2 into x plus 0.2 into y, expectation of that is equal to 0.2 into expectation of x plus 0.2 into expectation of y. We already know that for uniform distribution, the expectation of any variable is a plus b by 2. In this case, first variable, we know that the range is what, 50,000 to 60,000, though a plus b by 2 is 55,000. You get mid value of that, that's all. So here x follows uniform distribution, it's given here. Okay, no need of, okay. So x follows uniform distribution 50,000 and 60,000. So mean equal to sum of this divided by 2, that's equal to 55,000. And like variance equal to what, b minus a the whole square divided by 2, that is equal to 60,000 minus 50,000 the whole square divided by 2, that's equal to 10 raised to 8 divided by 2. This is 10,000 the whole square, that's equal to 10 raised to 8 divided by 2. Similarly, y follows uniform distribution in this range 50,000 60,000, mean equal to sum of these two divided by 2, a plus b by 2, that's equal to 50,000, and variance equal to 40,000 50,000 divided by 12, that's equal to 10 raised to 8 by 3. Okay, don't be surprised to get variance this big number, because always the variance will be of the magnitude of square of the change. Here, since this 50,000 and 60,000 are big numbers, the change will be in that range itself, means maybe 10,000 or 10,000, that much, either one variable to one value to another value, that kind of changes, variance will be, high variance will be there in an order of 10,000, like this it will become. So this it will be squared always. Sigma square means that will be squared. Standard deviation represents the exact variance, means exact variation or change one value to other. It's a measure of that change. Variance is a measure of the square of the change. So 10 raised to 8, don't be surprised with getting this big number. 10 raised to 8 by 12. Similarly here 10 raised to 8 by 3 we will get squared by 12, b minus a the whole square by 12. And expectation of u equal to, similar way, we know that expectation of u equal to what is that? Expectation of 0. You can take the constant outside, it's linear. 0.2x plus 0.2y equal to 0.2 into expectation of x plus 0.2 into expectation of y. That is expectation of u equal to 0.2 into expectation of x plus 0.2 into expectation of y. Substituting here the expectation of x is that, expectation of y is that, substituting that thing, we will get 21,000. That's the expected value profit. And for variance, we need to take this independent. Sigma square of u equal to sigma square into 0.2x into 0.2y. So only because of x and y are independents, we can take this equation like this: 0.2 square into sigma square x plus 0.2 square into sigma square y. That's equal to 0.04 into 10 raised to 8 by 12 plus 10 raised to 8 by 13. That's equal to 5 into 10 raised to 6 by 3. So these are what about covariance and expectation. We will see more problems later. In next lecture, we will discuss about what is conditional distribution and what is conditional expectation. Like that. Conditional distribution is nothing but when the other variable is restricted. If x and y are two random variables, if y is taking 2, then what will be the probability of x? Like that. It's very much different from marginal distribution. Marginal distribution is even if y is taken whatever the value, what will be the probability of x? We don't know about y. So in conditional distribution, if we given that y equal to 2, then what will be the value? What will be, then also x will be varied, then what will be the value y, x, like that. That kind of things will be discussed in conditional distribution and conditional expectation. That will be in next lecture. Okay, thank you.